So you can see I'm recording this in case you need to go back and check on something that I say during this review. But these are the basic things that are going to be on your quest. The first section of this part here was about atomic structure. And you'll notice that I wrote down the symbol for protons, neutrons, and electrons. That's because you need to know something about each of them. You need to know, first of all, their charge, which I indicated by writing the symbol for them. Protons are positive, neutrons are neutral, electrons are negative. You need to know about their location. So the fact that protons and neutrons are both in the nucleus. Electrons are in orbit, which is what occupies most of the volume of an atom, whereas the nucleus is really small. Protons and neutrons both have a mass of 1 atomic mass unit. Remember, that's a unit like a gram or a kilogram, but it just has a different value. They both have a mass. Electrons don't have a mass that we count. So for all three of the particles, you need to know where are they, what do they weigh, and what is their charge. And then for each particle, there are a few specific bits of information. For example, for a proton, you should know that it identifies the atom. So if I simply tell you something has 3 protons, no matter what else I tell you, you know that that's lithium. It has to be. That's the thing that's number 3 on your periodic table. So the number of protons equals the atomic number. Now, if we talk about neutrons, the way you figure out what a neutron, or how many neutrons there are, is mass minus atomic number, which is the number of protons. And remember that you have to round things. We also know that isotopes exist. An isotope is when you have 2 atoms of the same element, but they don't have the same number of neutrons, meaning their mass is different. Absolutely. So the periodic table that you have, that's what you get to use when you do a test. So you will have access to any data that's on your periodic table, so you wouldn't have to memorize anything that's on there. A common way that I would show you isotopes, for example, is by showing you the standard notation for an element. That's where I write the mass on top and the atomic number on the bottom. That would be a pretty typical way for me to show you about isotopes. That's the way I showed it in the notes as well. In terms of electrons, there's a little bit more that you have to know, because electrons are so important in terms of forming bonds. So the first thing that you should know about electrons is what an ion is, how you get a positive or a negative ion. So for example, if I said I have an ion of aluminum, I might ask you, what kind of ion is it? Since its charge is positive, you would say it's a cation. I might also ask you, did it gain or lose electrons? Since its charge is positive, it had to have lost electrons. The other thing you should know about electrons is about valence electrons and the octet rule. Valence electrons, you may remember, are the ones in the outermost energy level. And the octet rule is where atoms are trying to have a full valence energy level. For virtually every case, that means 8. You might recall that noble gases already have 8 valence electrons, so all the other atoms are trying to get like a noble gas. Some atoms will gain electrons, some atoms will lose them. But this idea of having a full set of valence electrons is definitely something, let's just even specify, that I would ask you to write about. because I find that to be a really difficult question to ask a good multiple choice question about. It's something that you need to be able to explain. Why would chlorine want to gain an electron? Well, it has 7 valence electrons and it wants 8. Why would sodium lose an electron? Well, it has 1 valence electron. It wants to lose that so that its next energy level becomes its valence level. That's something that you'll have to be able to explain. Why ions have gained or lost electrons. The other thing that I want to mention about atomic structure is that it's very probable that I ask you to make a picture of an atom or an ion or something. Remember specifically, let's say I'm going to make an ion of oxide. So that's an oxygen ion. In the nucleus, I would write that I have 8 protons and 8 neutrons. When I draw the electrons, I would remember I can only put 2 in the first energy level. And in the second energy level, since this is going to be an ion, I have to ask myself how many there should be. Ions should always have full valence shells. An atom of oxygen would have 8 electrons, but an ion of oxygen would have 10. So I would fill up this second energy level. So I just wanted to remind you about 2 electrons going in the first level, a maximum of 8 going in the second, and so on. Does anyone want to ask any questions about anything that has to do with atomic structure? So then the next section of this unit is the section about compounds. And quite frankly, since your lab is due tomorrow, if you do your lab, you will be studying for this part of the quest. The lab is asking you to look at properties, figure out what kind of compound that represents, and then pick a formula from a list. That's exactly what I would ask you to do. I would tell you the property of something and ask you what it was, or I would show you the formula for something and ask you what it was. So if you do your lab, you will have studied for this part of the quest. Just as an example, you would need to know things like ionic compounds conduct electricity, and a lot of them are soluble. Molecular compounds don't conduct and aren't soluble. Acids turn blue litmus red. Bases turn red litmus blue. Acids and bases both conduct electricity. So properties are descriptions like that. The other thing that your lab asks you to do is associate an actual formula with the properties that you came up with. So remember, an ionic compound should have an anion and a cation. Usually that means a metal and a non-metal. A molecular compound should have only nonmetals. An acid either starts with an H or ends with COOH in its formula, and acids have to be aqueous. A base looks like an ionic compound, but a base very specifically has hydroxide in it. The only exception to that I mentioned was ammonia. And so you can expect 2 different questions. One where I ask you about properties, and one where I ask you about formulas. Would anybody like to ask any questions about identifying which of those 4 types of compounds you have? Now keep in mind, I did not list every property in the universe there. I just put down a few as examples. Please refer to your notes for all of the properties of compounds that we discussed. The last thing then that's on the quest is naming. And so we just did this, but just to recap, for both ionic and molecular, you have to change the suffix. The only exception to that is in polyatomic ions. In ionic compounds, your goal is to balance charges with the lowest ratio you possibly can. In a molecular compound, the prefixes are what tell you how many you have of each atom. Those are the main principal ideas for naming things. Does anyone have any specific questions about nomenclature they'd like to ask? The dividing is for ionic. So when I write here with the lowest ratio, that would be where, for example, instead of writing PT2O4, I wrote PTO2. That's only for ionic compounds. Does anybody else have any questions they would like to ask about naming